Neoclassical economic theory, environmental economics.
In textbooks on economics, the creators of neoclassical economics, Stanley Jevons, Leon Walras, Francis Isidro Edgeworth, and Vilfredo Pareto, are credited with transforming the study of economics into a rigorously mathematical scientific discipline. There are, however, no mentions in these textbooks, or in all but a few books on the history of economic thought, of a rather salient fact: the progenitors of neoclassical economics, all of whom were trained as engineers, developed their theories by substituting economic constructs derived from classical economics for physical variables in the equations of mid-19th century theory in physics. The physics that the creators of neoclassical economics used as the template for their theories was developed from the 1840s to the 1860s. During this period, physicists responded to the inability of Newtonian mechanics to account for the phenomena of heat, light, and electricity with a profusion of hypotheses about matter and forces. In 1847, Hermann Ludwig Ferdinand von Helmholtz, one of the best-known and most widely respected physicists at this time, posited the existence of a vague and ill-defined energy that could unify these phenomena. This served as a catalyst for a movement in which physicists attempted to explain very diverse physical phenomena in terms of a unified and protean field of energy.
Because the physicists were unable to specify the actual character of this energy and could not be precise about what was being measured, their theories were not subject to repeatable experiments under controlled conditions.
Obviously, this violated one of the cardinal rules of the scientific method. The predictions of any scientific theory must be testable and potentially falsifiable in repeatable experiments under controlled conditions. The amorphous character of energy in the physical theories also obliged the physicists to appeal to the law of the conservation of energy. This appeal was necessary because it was the only means of asserting that the vaguely defined system somehow remains the same as it undergoes changes and transformations. In the mathematical formalism that resulted from these substitutions, the mind of atomized economic actors is presumed to operate within a field of force identified, in both figurative and literal terms, with energy. The forces associated with this energy were represented as prices and spatial coordinates described quantities of goods. Because utility energy in this formalism is conserved, the creators of neoclassical economic theory were obliged to view production and consumption of goods and commodities as physically neutral processes that do not alter the sum of utility. They did so by arriving at a very strange interpretation of the now outmoded law of the conservation of matter, or the idea that matter cannot be created or destroyed. If matter, they argued, is immutable, then the production of goods and commodities cannot alter or change the stuff out of which goods or commodities are made. They then claimed that any value which accrues as a result of production can only reside in the mental space of economic actors. In an effort to justify this conclusion, the economists argued that if the immutable stuff out of which goods or commodities are made cannot be changed by consumption, any value associated with consumption must reside in the minds of economic actors. This strange view of substance in economic reality was used to interpret the meaning of the economic variables in the equations borrowed from mid-19th century physics, and this served as part of the rationale for the theory of value in neoclassical economic theory. In the formalism of this theory, the atomized immaterial minds of economic actors operate within a field of force, utility, in which the natural laws of economics are presumed to legislate over the choices made by the actors. This became the basis for a fundamental assumption in neoclassical economic paradigm: the value assigned to all the immutable unchanging stuff that circulates in a closed loop from production to consumption in a market system results from the operation of the putative natural laws.